The double slit test is one of the most shocking things that you'll probably see in your life if you have any interest in nature. If you have a slit, right, and a projection screen behind the slit, and you have a lamp before the slit, and you throw light, if you want to, through the slit on the screen, you expect that you'll see a line, right? That's what you expect. And that is indeed what is happening. However, and you can do that test tonight if you don't believe me, if you do the same test with a double slit, come in, please come down. If you would do the same test with a double slit, you would expect that you would see two lines on the screen, right? And that is not true at all. You get a number of lines. You get a wave pattern. And this is one of the most exciting observations, and I repeat, you can observe that yourself tonight. As you take a lamp, you take a screen or something where there are two slits in there, you put a white wall behind that, you don't need a screen, you project on a white wall, and to your surprise, so you switch on the light, you have one light bulb that goes through the two slits, you will not have two lines. How is this possible? Now, this is one of the most remarkable observations, one of the beginning observations of what eventually became quantum mechanics. Clearly, those light photons, those elements of light, do not just follow a linear path. They do something so that if there's one slit, you see one line. If there are two slits, you get a wave pattern. And that will be the big issue in quantum mechanics. Is it a particle or is it a wave? Is it something which exists and doesn't change anymore, or is it a set of potentialities, possibilities? Quantum mechanics is the science of the possibilities, of the potentialities. Right? That is quantum mechanics. By the way, quantum mechanics is nothing more than the study of the very small world. That's what means quantum mechanics. There's nothing exotic about it. It's just a study of how life behaves in a very, very, very small space, big amounts of energy, etc. That is quantum mechanics. Right? Once you've seen that, if you've never seen that, I promise that it's going to change your life. In quantum mechanics, just like in Indian philosophy, one ball, can go through two holes at the same time. That's quantum mechanics, right? And there have been tests going on, and the scientists will talk about that, to try and follow the pattern of a light photon, right? And see if the light photon is beamed, what pattern it follows, and how it is possible that it does not project that one line, but that it projects that wavelength. There's a second very interesting observation in quantum mechanics, and there's a third one. There's a second, which now means that according to the being there of an observer or not being there, the projection of the light changes. So, if you have an observer that observes the two-slit problem, you do get two lines. Now that becomes completely incredible, isn't it? But it is true. So you have the same thing as a minute ago, one light bulb, two slits, you get many lines. Now you have the same experiment, but you have an observer. You have somebody who watches those slits, right? Who tries to identify through which of the two slits the light photon goes, and to everybody's surprise, suddenly the pattern changes. Now, it becomes even worse. Some people say, is it the physical observation that makes the light change? By the way, we still don't know how that works. We observe it, we don't know what the mechanism is behind that. And then they started to do tests where they put the observer in another room. So the observer doesn't physically observe anymore. The observer concentrates. So I do my experiment here, and I put you, observer, out there behind the door, and I say, you've seen the thing, now you're going to concentrate on watching to the slit. And again, if you send the light through the slit, you get two nice lines. Amazing. In classical Newtonian physics, this is of course completely impossible. However, you can do that yourself. I repeat, do it tonight, you'll see it, and you can do it yourself. There's no magic behind that. That is the second very remarkable observation that quantum mechanics have done. The third observation that quantum mechanics have done is there seems to be hence something with those light photons. Now, if two light photons ever have been together in an atom, and you would artificially separate them, and you would act on one of those photons, immediately and without any time delay, the other photon reacts. So there seems to be an interaction at a distance, which the quantum mechanics will call non-locality, and there seems to be an interaction at the same moment, which the quantum mechanics call synchronicity. We often think that there's something like coincidence that exists. You know, you want to call somebody, that somebody calls you. Oh, that's a coincidence. That is no coincidence. That is synchronicity. And the reason of that synchronicity, I'll get to that, since that's the third characteristic of the quantum world. The first is non-locality, the second is synchronicity, the third one is entanglement. I'll explain that in a minute, right? Due to entanglement, you get something like what we like to call coincidence. Coincidence, we often think that it is by accident. Coincidence is not by accident. Coincidence is created by yourself. The essential thing, and I go back to my double-slit experiment, the essential thing seems to be in quantum mechanics that the observer does play a role. For your information, that is what Varela told us already, that is what Sheldrick told us already, so it is not new. We've seen that in other sciences. But in quantum mechanics, it appears to be clear that the observer matters, and according whether there is or not an observer, you see different things. Now, that means that actually, according to quantum mechanics, it is the observer that creates the reality. The observer watches the double slit, you get two lines. The observer doesn't watch the slit, you get a wave. Now I go one step further. We don't have windows, unfortunately. If I would ask you whether there is a tree over there, for you there is no tree. Now believe me, there is one. I've seen it before. But for you there isn't. When is there a tree for you? There is a tree for you when you would see it. Does that mean that the tree only exists when you see it? Or does the tree always exist? Quantum mechanics tells you that the tree only exists when you see it. And that's the famous Schrödinger cat paradox. Schrödinger is one of the big quantum mechanics, and he came up with a thought experiment. So those of you that like animals, it's just a thought experiment. You have a cat, you have a time mechanism, and you have a poisoning system. You have one chance out of two that the time mechanism goes off in 1 hour time. If the time mechanism goes off, the poison pill opens, the cat dies. Okay? You put all that in a closed box. What is the chance that the cat is dead after 1 hour? 1 out of 2, 50%. Do you know whether the cat is dead after 1 hour?